Hello, Open XML developers. This is Eric White. Today I am super happy to announce a new implementation of the SystemIOPackaging namespace. As many of you know, the Open XML SDK is based on the classes in SystemIOPackaging. This means that if there is a bug in SystemIOPackaging, then that bug is also in the Open XML SDK. Well, there is a bug. Actually, it's more like this bug. Here is the gist of the bug. If memory usage goes above 10 megabyte, then System.io.packaging uses System.io.isolated storage. It pushes extra data out to isolated storage. Isolated storage puts information in a directory, the name of which is based on the strong name of the assembly that is using it. Isolated storage is not prepared for two executables with the same strong name or multiple threads which come from an assembly with a single strong name. It's not prepared to allow access by two executables or threads simultaneously. The bug will occur if and only if two executables or threads each exceed 10 megabytes of memory use simultaneously. This is the worst kind of bug. You do something and something completely unrelated in a completely different area of the system blows up quite some time later. It's bad. The problem is System.io.packaging can't be changed. The module has been frozen for some years. Further, it was based on some early internal zip implementation that had issues. If you want to look at that code, all of these files are available in the reference source that you can access on MSDN to the various versions of the .NET framework. But suffice it to say, System.io.packaging was not going to get updated and it was not going to be fixed. However, there is a new good zip file implementation in the System.io.compression namespace. This was not available when System.io.packaging was originally written. Well, we need to kill this bug. The solution to this is to build a new System.io.packaging that is based on System.io.compression. We'll make it open source. We'll put it into COREFX, which is the new open source .NET framework being put together, and we'll also construct it in such a way that it can be used with the .NET Framework 4.5. Then we're going to use this System.io.packaging, not the one that is in Windows Base.dll. I have recently completed this implementation and there is not a whiff of isolated storage in this new module. Next thing I'm going to do in this screencast is I'm going to go through the process of downloading the Open XML SDK repository, building it, and putting together an example application. First thing to do is to clone the Open XML SDK repository. Next, open a Visual Studio 2013 command prompt. 2012 works just as well. You will notice two sets of solutions and projects in this directory. This solution and this project with this suffix orig-sip, this links with the original System.io.packaging that's in the .NET framework and is in the Windows base assembly. The solution named Open-XML-SDK.sln, this links with another project that is in System.io.packaging, and all of the source code for this new System.io.packaging is contained in this directory. Building the Open XML SDK solution, that will also build the library for the new System.io.packaging. We can build this just by typing ms build Open XML SDK.sln. And it finished. We will see some warnings around the issue that some of the types in System.io.packaging are not CLS compliant. This is the same as it's always been. We may address these warnings at some point in the future. In any case, it's not a serious problem. Now that we've built the libraries, let's build a little example and show using those libraries. Let's create a new project. We'll create a Windows Desktop Console application. We'll base it off of the .NET Framework 4.5, although it works equally as well with 4.5.1, 4.5.2. We'll call it Console Application 1, and we'll put it into some directory. Let's add references to our new assemblies we just built. We'll browse to the Open XML SDK directory where we have our repo and where we just built these libraries. I'll go into the build, Open XML SDK Lib, go into debug, and I want to grab both of these assemblies, both the document format .openxml.dll and system.io.packaging.dll. Add both of those fellows in there. And here is about the simplest Open XML program that we could write. It simply opens up a word processing document named test.docx, and it goes into the main document part and counts the number of descendant elements. We'll need a test.docx, so let's go create one of those, and I'll run this little application. And it tells us there were 11 descendant elements, so everything worked just perfectly. An application built in this fashion will not have that 10 megabyte issue. Given that the main motivation behind developing this new System.io.packaging is robustness and reliability, I think it's appropriate to show you how I developed this new System.io.packaging module and how I gave it robustness and reliability. This is particularly important to you if you're building a mission-critical enterprise application that runs on servers or whatnot. These are the types of things that people build with the Open XML SDK. Reliability is of the utmost importance. So I'm going to just walk through a little bit and tell you how I built this new System.io.packaging. It'll be interesting to some of you. First thing I did is I put together a document that describes exactly the surface area of the API that I was going to create. I listed out all of the types, and I listed out any particular differences between what I was going to implement and what's in the .NET framework. To the extent possible, I modified code as little as possible, except for the code to access zip files, and that was a wholesale rip and replace. There were a lot of changes in those areas, but there were other areas where I kept the changes to an absolute minimum. There were two areas that I did not implement in this new System.io.packaging, and these are the areas of encryption and digital signatures. We have not yet determined our plans for supporting these features. In any case, if you need to use these features, then you can certainly use the System.io.packaging that's in the .NET framework. The next thing that I did is I wrote 122 XUnit tests that cover the desired API and cause a high level of code coverage in the library. These tests run identically on the System.io.packaging that's in the .NET framework, with the exception that in a couple of cases, my new System.io.packaging performs correctly, whereas the one in the .NET framework did not. But these were not serious issues, just a case where the original System.io.packaging was throwing the wrong exception in some error situations. One interesting aspect of OpenXML development is the vast varieties of documents in existence. I have a document library with approximately 370,000 OpenXML documents of all varieties in it. As a test to check out the ability of the new System.io.packaging to process these files, I put together a test that does the following. The first thing that my test does is it validates the file per the Open XML SDK. This opens the file using the Open XML SDK, which is based on and uses the new SystemIOPackaging. It then validates the file. The test validates against Office 2007, 2010, and 2013. It then stashes away the results of this validation. Then it clones that file into a new file using SystemIOPackaging. It iterates through all of the parts and relationships in the original file and moves them over or copies them over into the new package. It then validates this cloned file. It then compares the validation of the file before cloning with System.io.packaging and with the validation after cloning, and those two validations must be the same. In other words, if there was an error per the Open XML SDK before cloning, then there should be the exact same error as found by the Open XML SDK after cloning. But the issue is to run all 370,000 documents through this process would take about 50 hours. Therefore, I used another tool that I developed. I've blogged about this before, called OX Runner. In my office, I have quite a stack of quad-core machines set up to help me in doing massive bulk tests in this fashion. I developed this test harness called OX Runner that enables OpenXML processing to be farmed out to all of these many machines. And further, on each one of these machines, I run 5 processes simultaneously, thereby using the CPU capabilities to the maximum extent. And using this approach, I can run this test on all 370,000 documents in less than 2 hours. Of course, in the process of running these tests on all of these documents, I got a report showing any documents that failed for any reason or other. I found issues, I fixed them, and I repeated this process until this process ran clean for all 370,000 documents. The end result of all of this is that we now have a new System.io.packaging that performs identically to the old one and will never use isolated storage and therefore will never exhibit this 10 megabyte bug. This new module is undoubtedly more robust now than the one that is in the .NET framework. It's the module that I'll be personally using going forward. Thanks for watching. See you in the next video.